I think this one will be easier than last time because grabbing actually wasn't that much of a challenge and I don't have to fight with the navigation system. So, like in the blueprint example, we want to implement a couple of different types of grabbing. We want to implement grip, which is when you put your hand onto an object and hit a button and then you can move it around, you know, like the most basic type of grabbing, like what you would do in real life. Then we had two types of force grab. We had force grab without snapping, which is, you know, like Darth Vader choking that guy, except the guy is kind of far from his hand. So, you know, you can grab something from afar, but it will still remain at that position, but you can still move it. Then we had force grab with snap, which is when you point at something, hit a button, and then it snaps to your hand. So it's like yoinking it towards you. Then finally we have magnetic grip, where you hit a button and the closest object to you, it comes to your hand. And it's that simple. So we're going to implement these, and if you recall, they actually share a lot of code. But I'll try to do them as sequentially as possible. So, oh, where did my Visual Studio go? UE4. First one is grabbing. Actually, let me make inputs for all these things. So, we have, I'll call it grip. And all the grabbing I'm going to do on my right controller. 5 are grip, which are the side buttons on the Vive controller. The shoot and grab no snap will be the up button on the touchpad. 5 are up. Then I had shoot, oh whoops. Then I had shoot and grab snap. And I'll make that one left on the touchpad. 5 are trackpad left. And finally we have magnetic grip. And I'll make this down. 5 are trackpad down. So here are our inputs, which will bind to functions, as we've been doing so many times already. Get rid of these things. So yeah, we have these inputs and we'll hit them and they'll do different things. So we just need to bind more actions, which at this point, it's something we've done enough times that it should be second nature. I'll copy my code from before because it's just, you know, it's just what we've been doing over and over again. And I have pressed and released versions of these functions, and I need to declare all of these. So, also some of my inputs I named differently. Magnetic grip, this one was called grab right before, not drip. Oh my god, I can't spell. This it was called grab right before. I'm gonna call it grip this time, and I'll call it grip here too. Grip, grip, grip. And in the header, I will add these declarations. And as usual, I'll just kind of copy these. Well, copy most of them. Sorry, it's from another project. So I'm gonna ignore let go, even though you probably know what that's for. Force grab, grab right pressed is now grip pressed. This one is grip released. And now I need to add these. You can just do this as well. You can, oh my god, waiting for IntelliSense to do anything means that it's never going to get done. I didn't think it would actually use IntelliSense just to add a couple of lines to the file, but I guess it will. I'm tempted to just kind of add these myself, because waiting for IntelliSense means that it's just not going to happen. It's literally not even worth waiting for. Yeah, I'm just going to add it myself. Add these. Let me not add this yet. And grab magnetic grip. Shoot gun. I had some my order was all over the place. Shoot and grab, no snap pressed, released. Shoot and grab, release. Okay, here we go. I'm gonna add these to the body file. Get rid of the U functions. Replace these with curlies. And finally add the class name. And there we go. Hopefully that should be all we need to do, except for grip. Well, grip pressed, grip released. That looks fine. It looks like it found them. So this should compile just fine. Yeah, so it's updating for now. First, we're going to do grip. So when I hit the grip button, the first thing I want to do is just show on my text in front of my face that it's actually doing that. So, do this. Grip. And I'll have one for release. Grip release. I'll actually do this for all of these. So, no snap. No snap release. Snap. Just as a sanity check to make sure I'm actually hitting the buttons, and also because you can't tell which buttons I'm hitting. So here we are with these. Now for gripping, I want to put my hand on the object to grab it. I don't know why this is happening. Okay, that was weird. I want to put my hand on top of these objects and grab them. And I'm actually gonna, just because I'm lazy, I'm gonna move these closer to the front so I don't have to reach so far into the table, and I'll add some more of them for funsies. Let's see, just to kind of test this quickly, what I want to do is too high up. Come here and put my cone on top of here and then grab them. Right now, grabbing is not actually working, so it's kind of sad. This may not be considered the right controller. That would be irritating. No, it is. It's not adding them for some other reason. Let's see. None of these buttons are working. Oh, it's our favorite problem. The editor is not updated. Anyway, that's the idea. We want to put our cone on top of these objects and grab them. And in Blueprint, we use this function, get overlapping actors, which is a nice function in Unreal that you can use to tell if some component is overlapping with another actor. In our case, we want to test if the cone, which is called right mesh, is overlapping with one of the collectibles. And C++ has that same function. So to get this function to work, you need to, like with the raycasting, you need to have some kind of output for it to send it to. So you can see that here, when you see this @ symbol, it means that they want you to give them an array to fill. So you need to declare an array, and they will fill it with the actors that are overlapping. And you can also see the out here. So that's what we'll do. So grip, shoot gun, pressed. Maybe I forgot to delete one of these. 87. Oh yeah, I just kind of forgot that. So I want to do that. T-actor array. This is what I did. I'm going to copy this so that I don't have to type it all out. So I declared an array with a bunch of actor pointers called outOverlap, and get overlapping actors, which is called on my right cone, will fill this array with actors that I'm grabbing. So to test if I'm overlapping with anything, I can just check the size of this array. Now, remember T-array is Unreal's version of standard vector that it wants you to use, and its array size is num, which is a really weird name. I don't know why they call it this instead of just length or size, which is what every other programming language ever uses, but this is what we have to use. So if you are actually overlapping with something, then for now what we'll do is just put on our output text what the name of the thing that we're overlapping is, at least the first one. Because it is possible for you to overlap with multiple things, like if the cone is partially on another one of the cubes. Go to there, conflicts with another function. The problems with copying code. Any day now. Alright, so it should print what I overlapped with once I hit the grip button. First of all, let's make sure that the controls work this time. I also need to see grip, release, snap, no snap, magnetic. So when I hit grip, when my cone is interacting with something, I should be able to get its name. See? Editor cube 35 is this one, I guess. This is 30, this is 25. So this is working fine. The thing to remember, and I think we already handled this at some point with the bullets, but to actually get, I believe that to get overlapping actors to return anything, you need to make sure that the cubes are set to generate overlap events, which they are. Otherwise, they won't do anything. But fortunately, they're already set that way. So, for example, right here, it's generate overlap events, which I think is the defaults for static meshes anyway. But this needs to be set to be true for them to do anything. Well, it needs to be set to get overlap events, and it also needs to have some kind of collision. Right now, it's default collision, which is fine. It should actually, ideally it should be physics body, so in the constructor of the collectible you would want to change it to a physics body. But default should be fine. And yeah, if it's no collision but you have generate overlap events to true, it still won't do anything because it doesn't have a collision. So yeah, this is fine right now. So now that we know that we are kitting things, just like in Blueprint, we want to make sure that well, let me demonstrate quickly. I can grip something that is not a cube and it will still return that message because it doesn't really care what I'm grabbing. So, well, I guess in this case it does because these white cubes are not set to overlap, but it might cause a problem with like bullets. So if I shoot some bullets, I have to go there and grab them. Come here. Stop. Stop. Oh god. Come back. Oh my god, I can't even reach it. Whatever. I was gonna show that you can. If something else is set to generate overlap events like this thing, it will probably cause problems. Let me set this to be in the right position. It's above the ground. It should actually be like here, because you spawn your player's VR center will be in the middle of this capsule collider. Now that I enabled overlap events for this white cube, it should actually show this point. See, editor cube 22 is this white one, and it returns this. So we again need to cast into one of our collectibles, which we know how to do already. So I have this cast with our good old dynamic cast, which does work correctly, unlike the Java style cast. And if this object is not null, which you could explicitly do is not equal to null pointer, which is the null of C++, but testing if it exists at all, which is what I'm doing here, is sufficient for that. I had an output before that succeed. It's probably not a good, it's not a useful message, but the first thing that we want to do is, well, naively, let's say that we do exactly. Okay, so in C++ you don't have weld simulated bodies like this, at least as far as I know, or as far as I tested. Let me test quickly, or check UE4 C++ weld simulated bodies. I don't think it exists in here. Yeah, it seems like it's not in the API, otherwise it would have shown up immediately. So in C++ you don't have this weld simulated bodies, which basically disables physics for the thing that you're attaching. So we need to do that ourselves. We need to disable physics for the cube, otherwise it'll just not do anything. But naively, let's say that we do the exact same thing we're doing in Blueprint right now. So we're doing attach, and it's attached to component because we're attaching it to our cone, which is a component, it's not an actor. Try cast attached to components. The first parameter is the parent of the thing that you're attaching, and then you have some rules for attachment. If you remember if you've used my Unity code, I actually made I made a Unity enum that was kind of the same as this. And Visual Studio is not helping with the autocomplete, but that's fine for now. Let's say naively we do attach to component. This won't work the way that we expect it to, because I'm not disabling physics. A actor attached to components. Yeah, I'm pretty confident there is no such weld simulated actors in C++. Anyway, it's compiled, so if we go and try to grab things, it says succeed, which means it got into that loop, but it's not doing anything because the cube still has physics, and the physics engine, I believe the physics engine takes precedence. So you don't even see it interpolating poorly. It's just not responding at all to the attachment, even if it might be attached. So we need to disable physics ourselves. Now, naively, let's say that I just do, in Blueprint you have set simulate physics. Right, let's say that naively I only do set simulate physics. This also won't be enough. Also, something that I found out on accident is that I think that set simulate physics needs to happen before the attachment for it to work at all. You know, if it were worth the time, I would show you that it doesn't work, but it really is just like one of those random things that I learned on accident through testing it. So I'm just telling you now that set simulate physics will have to happen before attach the component, or it probably won't do anything. Maybe I'll test it later in this video. So set simulate physics I set to be false for the thing that I'm grabbing. And I thought that would not work. That's fine. Set simulate physics is false. But I thought I would also have to disable gravity. I guess this time it's cooperating. But we can still explicitly set gravity to be false. It's also stuck to my hand, so when I release, it's not letting go. So we need to handle that somehow. What I thought would not work, that's working fine now, is I thought we would also need to explicitly disable gravity, which I'll do anyway because I think I did this in the Unity code. But you should disable gravity yourself. I would imagine it probably has some weird consequences if you don't. Anyway, we want to be able to let go of it now. You might recall that in the Blueprint code, since letting go of the object that you grab works pretty much the same way for all of these functions, I just made a let go function to use for all of them. And I will throw this in here. So this let go function will just generically let go of whatever I'm holding after grabbing it with any of these methods. In order to let go of the thing that I grabbed, I need to know what it is, and the easiest way to do that is to save the results of this get overlapping actors. And I made this variable called thing I grabbed, which is the thing that I grabbed. Delete this. And so thing I grabbed will be equal to this the casted collectible. And so now I have a reference to this thing that I'm holding, and I can use the let go function to let go of it. So when gripper is released, I can call let go. And actually when any of these are released, I can call let go. And let go is pretty simple. Let go is pretty simple. If you remember from blueprints, where is let go? In blueprints, there's a lot of extra code here because of a task that we did later, which was be able to attach it to the gun. But in blueprint, we did this. We just called detach from actor on. Well, this is the part that we care about. So the thing I grabbed, we detached it. If there is a thing I grabbed, first of all, so here, then we detach it. Detach from actor just detaches it from whatever actor it's attached to. You can only be attached to one actor at once, I think. Then we told it to simulate physics again, and then we nullified thing I grabbed, and we'll do the same thing here. So yeah, let's do this. If thing I grabbed, we detach it, tell it to simulate physics, and then nullify thing I grabbed, so that if I don't do this, then let's say that I let go of an object that I'm actually holding, and then I hit the grip button, and then I don't actually grab anything, and then I let go. I guess I wouldn't do anything in this case. It would just have weird, unintended consequences, unforeseen consequences from Half-Life Alyx. I guess I wouldn't do anything. It could cause a crash maybe at some point, but in any case, we should nullify thing I grabbed because we're not grabbing it anymore. Moving on. Compile, and the code for letting go of things will be more complicated when we add the gun feature, but let's not worry about that yet. I'll wait for this to compile. And then the other methods are not as bad at all. So this should work. If I do this, and then I can let it go. But gravity is still messed up. So I need to tell it to have gravity. It's because I explicitly disabled gravity before. Something that I wonder, I mean, sure, we can re-enable gravity down here. Something I wonder is, do I actually need to disable gravity? I thought I did, but maybe you just don't. I wonder what will happen if you don't do that at all. Out of curiosity, oh man, navigation mesh is now too strict when it wasn't working at all before. If I pick this up, alright, I guess you don't have to deal with gravity at all. I guess set simulate physics already implies gravity being disabled. I didn't think it is. I didn't think it did, but maybe that was just some bug in my code when I was testing this a week ago. Well, seems to work. Our basic grip and the cube seem to be a good weight. And yeah, physics is working. Cool. So now we can handle the other grab methods, which will be pretty similar except with raycasting. And we already have raycasting code from before. So this part's actually relatively simple, which is why I'm recording it sooner. So let's do these. Shoot and grab, no snap. So shoot and grab will basically do the same raycast that we used for the navigation mesh, like I'll point, or for teleporting. So I'll point my cone at the thing I want to grab and then hit a button, and then it'll grab it and keep it at a distance. But it is still basically the same raycast. I forgot I need these things as well, because these are parameters to this. So we are doing basically the same raycast, and now all that really changes is what we do with it. This is actually a case where whether or not you hit an actor, or whether or not you try to grab an actor versus a nav mesh, is actually pretty important. Actually, it might not be. I guess dynamic cast would handle this, but in any case, it's just good practice to check to make sure you have an actor. Then with this get actor, we will, we'll basically just do what we were doing here. So we will try to cast it. And if we successfully casted it, then we'll print out its name. And then we'll kind of just do what we were doing before. I mean, the grabbing code I think is a lot simpler than all the setup and fighting with Visual Studio. So, once again, we will attach to components, except the rules change this time. We want to, for no snap, we want it to keep its world transform. So we want the cube to stay where it was when we grabbed it, except now we grab it, so we're also moving it. And thing I grabbed will also be this. So this is simple enough. We're doing the same recast as teleporting, and then the rest of the code is the same as when we gripped it. So, I mean, this should just kind of work. Oh, compiling. After getting used to Blueprint's almost non-existent compile time, it's really hard to do things in C++. Compile time takes so long. You never really appreciate it until you start using Blueprint. So what is it called? No snap. Yeah, this one. So I can do this. This is no snap. And you can see it's working fine. Pew, 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 pew. And I already handled let go because I used that same let go function that just nullifies thing I grabbed and detaches it. So I can launch these things like this. So yeah, easy enough. And the snap version shares basically all of the code except the transform rules are slightly different. So we are just going to share this code. And I'm going to make a function that does this for me. So I made a function called force grab. In Blueprint, it was easy to have things share code because you can have them convert. Well, in Blueprint, I still made a function for this, but in Blueprint, you can have lines, these white lines converge onto code to have them share code. But making a function in C++ is how you do it, the old-fashioned way. So in force grab, when I did this in Blueprint, I was testing the key press to make sure that it was the Oculus A button in that case, or in this case the Vive, whatever I'm doing. In this case, it's easier to just use a Boolean, just say like snap or no snap. So I have a bool that is snap, and maybe for once I should use a normal naming convention. So should snap, boy should snap, that in there. I don't need to worry about it being a U function because it's not being bound to any normal Unreal function. And all of this code will be shared between snap and no snap, except the rules will be different. So if snap is true, then actually this is pretty cool, so I want it to autocomplete, because there's actually this really nice property inside of F attachment transform rules in C++ that Blueprint doesn't have, which does exactly what I like to do, which is snap the location and rotation, but not the scale. So I just wanted to actually compile for once. Compiled. Oh, but I didn't do it in Visual Studio, which means that... Oh, there we go. I didn't think it would work. So if snap, then F attachments transform rules, and then there is this really nice one that I like, snap to target not including scale. So this will snap the location and rotation but not the scale, The reason that we don't want to snap the scale is because my cone is whatever scale it is right now, like 0.1, 0.1, 0.1. And so if I tell the cube to adopt the cone's scale, it will shrink when I grab it, which I don't want to happen. Or snap, this is the ternary operator. No, this is it. If snap is true, it will do this. Otherwise, it will do this. And so inside of the no snap function, all I need to do is call force grab false. And inside of the, or sorry, no snap, I call false. And in snap, I call true. And that handles both of these cases pretty elegantly. Oh, should snap. Naming conventions are fun. So this is easy enough. Magnetic grip is a little bit of a pain, as we'll see soon. But these other ones are very simple. And our put the cube on the gun feature is also simple enough. So testing this out, I now have snap and no snap. So this is okay, I was confused for a second because I thought mag was shooting raycasts, but I think it's just because the Vive trackpad is a piece of trash, so it's hard to tell if I'm hitting the right button. Anyway, so here is snap. So it teleports my hand, and I can let it go and throw it. Shoo. And then I have no snap, which will do this. And you know, all my gun mechanics still work fine. And I can still grab the cubes, and they're colorful now. Oh my god, my aim's not good enough. So yeah, this works fine. And it's it was simple enough to get these to share code. You know, arguably it's easier to get it to share code in C++ than it is Blueprint, just because people have experience with this kind of thing in Java or C, so it may be a little bit more intuitive for undergrads in C++ than Blueprint. Unless you already know Blueprint, then it's harder in C++ probably. Anyway, now we'll do magnetic grip. And the only thing that makes magnetic grip annoying is that the parameters can be hard to write. So, with magnetic grip, remember we want to, the main difference between magnetic grip and the other grips is that with magnetic grip, you use a sphere trace. So it draws a sphere around your hand, and then it grabs the closest thing. And here we've already solved the problem of multi, but let's say naively for us to see what happens, we'll use sphere trace single instead and just grab the first thing it hits. So one benefit of using Kismet system library is that I don't think that the regular get worlds includes any sphere cast. I think it only has line casting. Line trace single. It does have asynchronous line tracing, but line tracing is so lightweight that it's almost not even worth dealing with that. In any case, unless you're doing like ray tracing or path tracing or something like that. Anyway, Kismet system library has sphere casting, the regular way doesn't. So it's just you know, that's the moral of the story. So the parameters for for sphere tracing are pretty much the same as before. So we still are going to get a hit and the rest of it is pretty much the same. If Kismet system library. Sphere trace. Let's naively do single for objects. Has some parameters, so you want your get worlds. The start vector is going to still be your hand, right mesh, gets component location. Now, if you recall this weird nuance of sphere tracing, what sphere tracing is actually doing is it's taking a sphere and then it's dragging it across a line, and it's returning everything that sphere hits when it moves across the line. If you give it the same start and end location, it actually doesn't do anything because the sphere is not moving along the line. So it's a kind of confusing thing. Like, why couldn't they just make it so that you radiate from a point, like the physics overlap sphere in Unity? I don't know. I mean, I guess there are benefits of doing it this way. For example, if you wanted to ray trace, if you wanted to raycast, but you didn't want maybe you don't want the user to point, like maybe you have some amount of inaccuracy, like maybe the user can miss by a little bit, the radius of the sphere can be that amount of permitted inaccuracy, and it would still return something that they hit that's pretty close to the ray, but maybe not on the line itself. I guess that's the main benefit of using sphere tracing, like taking advantage of the fact that it drags along the line. But for now, I'm just going to use it as if it's physics.overlap sphere. And so the trick to kind of get components location, the trick to kind of force it to work like physics overlap sphere, like radiate from a single point, is to just add a very tiny vector to it. So plus f vector, f vector 0, 0, I made 0.1 f is fine. It's like 1 decimeter, which is, or no, not a decimeter. I don't know what 1/10 of a centimeter is. Millimeter? Yeah, my brain's not working today. Then it wants the radius of the sphere. I'm just going to make it gigantic because I want the closest object no matter how far it is. Then this other array is a thing that is a little bit weird. It still asks, this array still is, you know, what types of objects do you want to query? It's just the way that you actually declare it is kind of strange because it's a T array instead of just a single, you know, trace type like with regular raycasting. So we need to handle that and give them the array that they want. So they were asking for this specific array. It's an array of these bytes that are types of object queries, which are the same type as these. So you can still use convert to trace type, or actually we have to use convert to object type because they want an object type query instead of a trace type query. See, this one wanted a trace type query, the other one wanted object type. Fortunately, there's a function convert to object type which we can use. I don't know, these are just like these are these annoying little subtleties in the C++ version of the code. And my favorite thing about Blueprint is that it abstracts these, but in C++ we actually do need to handle them. So I wanted to query physics bodies, which are our cubes. Or actually, our cubes are not physics bodies. Let's force it to be a physics body. Simulate physics is true. To force it to be a physics body, set simulate physics to true should actually force it to be a physics body. Weird. Whatever. We can handle this some other way, some other time. Set notify rigid body collision. Maybe that will force it to do that. Like in, like what we did with the bullets. Maybe this will force them to be, maybe this will force them to be physics bodies. I don't exactly remember how you do this, but it's simple enough, I think. Collectible.cpp. I'm trying to see if I've done this before. I'm pretty sure I have, I just don't remember how. It's in something called collision response, I think. Compile failed. Syntax error. Oh yeah, I know I didn't actually finish this code. Let me comment this out quickly. I just want to force these things to be physics bodies. The way that I think you do that is... This may work. Otherwise, I'll try to force it to do sets collision. Oh, I can't spell. Get static mesh components. Sets collision profile name. And it is an F name. Physics body. Maybe that'll be enough. Unless this F name thing becomes a problem. We might just have to do some kind of no, I didn't care. Collision block all. Why? Set collision profile name. Oh, the profile name might not be. It might not actually be a physics body. Physics actor. That's what I want. I don't know why it defaulted to block all. That's kind of interesting. You would think that it would default to default. There we go. So all these things, well, right now they're these, but defaults all of them to whatever their defaults were, which for all of these should be what the heck? Is one of these not an editor cube? I'm just gonna force them all to be physics actors. My guess is that one of these is not actually, like, maybe one of these didn't actually get converted to a collectible correctly. It looks like they did though, so I don't know what's going on. But anyway, if you were to create new ones, now they're physics actors. Physics body was object type, but setting the collision presets is good enough, I guess. Anyway, the benefit of this is that now I can add physics body specifically to these object types. So we can do object types dot add u engine types. We need to do the same thing where we convert the collision channel to an object type. Before we were doing trace type, now we need object types. The reason being that raycasts can, actually never mind, I'm not sure why. I was going to say that raycasts can hit things that overlap, but spherecasts can too. So I don't know why this is an object type. One of the mysteries of the Unreal C++ API. And this isn't helping me right now, but there is something called ECC physics body, which is it's physics bodies, so like our cubes now. Technically I could have done like all, probably. No. I probably would have needed to make it a physics body, because I don't know what defaults actually makes the object type, because you can't see it here. If you change the default, it doesn't show you anything. So I don't know. If I did block all, I think they would be dynamic or static. Static, even though they're not really static. So you just want to make sure that this object type is the same as this. Oh, it's not E-collision, it's E-collision type. Or E-collision channel. There we go. And this is just one of the options, so Destructible Visibility is anything that you can see, things like that. So we're using physics bodies. Now that we know that, we can feed this array into here. Object types. Now we need to give a trace complex. I'm going to say false because we're just dealing with cubes, which have very, very simple, very simple collision physics, because cubes are primitives. Actors to ignore is still ignored, but since there already is an ignore self parameter, I actually don't need to add myself. I'm going to still make this persistent because I want to see what it does. And out hit will be hits. Ignore self true again. All this other stuff is fine. So I'm not going to do anything yet. I want to show, I just wanted to demonstrate why we need to care about multiple traces. This single sphere trace doesn't actually return the closest thing to your hand. I'm not sure how it chooses what it returns when it's only supposed to return one thing. But it's definitely not the closest object. So let me test this. And if I hit my magnetic sphere button, you'll see that's where it hit right there, which is definitely not the closest sphere to me. I don't know where it hit now. Just kind of hits in random places. It's hitting all the way over there now. I didn't even know that those were physics bodies. So you can see that using single sphere tracing is clearly not enough, because it returns something else entirely. So yeah, it's a problem. If I have so many spheres, I don't even know where it's. Now it hit that over there. So what we need to do is sphere trace multi, which will return every single thing that it hits, and then iterate through and find the closest object to my hand. Sphere trace multi is, its signature is the same. The only difference is that it returns an array of hits. So T array F result hits, called hits, and it will return an array. By the way, that word function signature, that's worth knowing in general, just because you may run into that word. A function signature is basically the function definition without the names of the variables. So force grab, for example, has this name of its entire function, and its signature is, it has one parameter that's a bool. It doesn't matter what the name of the variable is, its signature is just that it has its first parameter as a bool. The reason that this is important is because for things like overlapping with the bullet or hits, when I bound on component hit to this event hit, when I do add dynamic, Unreal wants me to match the function signature. So it wants me to make sure that I have the first parameter as uPrimitive component star, second is aactor star, and so on. But it doesn't care what these names are. I can name these whatever I want. Because the function signature doesn't care what these names are. You may have seen this before, you may have not, but it's just a general piece of terminology that's is worth knowing. So sphere trace multi will return everything that it hits, and now I need to find the closest thing out of all those hits. And in my blueprint, I made a function get closest hit object, and this took in an array of these hits, and it returned the nearest object. And so I'm going to do the same thing. I'm going to make void avr cpp pawn gets closest hit object. This will take in a t array of hit results, and it will return a collectible star. And that's basically all I have to do for now. I just need to throw this in here. If hit result, throw this in here, remove this, remove S, put my semi, and that's all I need to do to create this function. And now this function will iterate through them and find the closest object. And this is a minimizer function, if you remember, which means that, so in Blueprint I had some local variables for the closest distance. So how far is the closest object that I have seen thus far? And I also keep a reference to what that object happens to be. And I initialize the closest distance to be a very high value because, or a very high initial value, because pretty much anything should be closer to it. So it's just a good initial value, because I'm not expecting anything to be farther than 1,000, or yeah, I'm not expecting the closest object to be more than 1,000 meters from my hand. That would be ridiculous. So we're going to do basically the same thing. We have these two local variables. We have the closest distance, which right now it's 100 meters. So I'll make it higher. 1,000 meters. Is that 1,000? 100 would be 1 centimeter. So this is a decimeter. This is a meter. Whatever. Arithmetic's not my strong suit. Initialize closest object to be null, and now I just do a for loop. For loops in C++ are actually pretty easy. They look the same as C#. So I'm iterating through all of the hit results in this array, and each individual element is called hit. So for each of these, what I will do is, remember that when I was showing you the sphere trace single example, it was also hitting these white cubes, and so I need to be wary of that. So I'm going to need to try cast the actual actor and make sure that this thing is in fact not null, meaning that it's a collectible, because I only want to grab collectibles. Then I'm just, in Blueprint I was doing this calculation. If you subtract two vectors, so if I subtract my hand location, or if I do my hand world location minus the hit actor's world location, that will give me a vector whose size or length or magnitude in Unity is the distance between these two things. And I still want to do that in C++. So I can do that same calculation. I'm copying this because laziness, and also because I think it's intuitive enough. So the calculation is basically the same. I'm doing if my right hand's mesh world location minus, so right hand's world location minus the location of this current hit's actor location, that will give me the size of that vector will give me the distance between these two things, and then I'm just checking to make sure if it's the closest thing that I have seen thus far. And if so, I will just save these things into these local variables. So closest distance will just be this exact distance because this is the closest thing that I've seen, or this is the closest, the thing that I have seen that is closest is of this distance away, and the closest object is the relevant one here. So that's basically it for finding the closest object. By the end of this for loop, we would have found the closest object, and we'll be returning that. And that's it. So for sphere trace multi, we'll just be calling this function that I just made, a collectible star nearest collectible equals gets closest hit object hits, and this function will return the nearest object, and nearest, I'll call it closest because I've been using that, closest objects. And from there we just do what we have been doing. Disable its physics and attach it. And we're just going to assume that it snaps because it'll be really confusing if you didn't snap it with magnetic grip, because you would be holding onto something but you wouldn't know where it is if it didn't snap to your hand. And then we add this pointer. And that's basically it. This should work fine. We've done our multi-sphere trace, where we found the closest object, and then we just did the same process as we have been doing. In fact, this process here could probably, you know, if you wanted to make your code cleaner or just avoid repetition in general, you could probably compress a lot of these things into one function. Like some function that's like attach thing to hand with rules. And that would just be a nice way of parameterizing it, probably. Did it compile? I wasn't paying attention. I guess so. Let's test it. Magnetic or snap is, oh, I did magnetic grip. See? You can see all these red cubes. Every time I do magnetic grip, it hits a lot of things. Yeah, that's just how it is, I guess. And also, because I have such a big sphere radius, I guess. But you can see it works. It brings the closest thing to my hand. I can throw it. My other things work. Snap. And no snap also works fine. So yeah, there are all my grab methods. And so all we need to do next is the very last feature that I need to add that I had from the lectures was you can grab something and then put it on your gun, and the cube would get stuck to your gun, and then you can shoot it instead of a bullet. And after that, we'll be done. That's the last of the content that I had from the class lectures. And from there you should, my first person controls still work even in VR. From there you should be able to, I think we've touched on enough, nuances of C++ that I think you should be in good shape to keep, to move on. But I'll get into that in the next tutorial. So I'm going to close off on this one. Bye.